unavoidable subject for today is troubleshooting. Your electrical system, you know the stuff's 30 years old, it doesn't owe you anything. That regulator on your firewall, that if you look real close, it says auto light on it, or maybe the later one said FOMOCO. It shouldn't still be there. No more than that Prestolite starter that's under there that weighs 17 pounds or more. But that's not our subject today. We're not selling anything. We're going to talk to you about what to do when your plane isn't working. So let's start with the starter circuit. And I use the AA5 series maintenance manual because there's more folks here with AA5 series airplanes, and the AA1 is very, very similar. If you'll note that picture, and it's very simple. There it is, you know. There's that big contactor right there. Do we still have that little sticky pin that he had me pointing at things? Oh well.
That was on my controller.
Oh, if I point the thing, it'd be nice. Anyway, that big solenoid contactor turns power to the starter. And you just got out there and you got your airplane. Well, let's see, like Mike Babbitt, very short time ago, yesterday. He gets in his airplane and he turns the master on and he pushes that good old start button and there's dead silence. Not a click, not a whir, not anything, just dead silence. I did it.
I'll show you all that.
Okay, that's fine. Right there. No, I mean, yes, there's a USB port right there. So.
Okay.
There you go.
As soon as it recognizes it, you'll be able to go forward and backwards, left and right, and situation.
Oh, that's okay. Thank you. What a wonderful gadget.
It really is.
It always has the top technology. Unlike our airplane. Anyway, that
I
doesn't.
have your parts in my airplane.
That solenoid isn't closing, which would connect the battery right there to the starter. Why didn't it do it? Because of the unlabeled fuse. Don't you love the unlabeled fuse? Right there is fuse. And it goes to this wall right here. And that's what's supposed to get it started. It has no label on it whatsoever. Okay, which one of you guys knows which fuse it is? Isn't that lovely? It's not even labeled in your airplane. But you do have a fuse in there, and it's not even the same on every airplane, but mostly it's the one that does the hour meter and the dome light.
I'll play with that.
Yeah, you know the one when you leave the thing there with the dome light on, it runs your battery down. Anyway, there is a fuse in there that is on this starter circuit here, and find that. That's simple. But the next one, you change the fuse and you push the button and you hear a clunk, and nothing else happens. It's time to whip out one of these things. Now, you don't have to have this wonderful $15 version. You could go to your local Kmart or Harbor Freight and get the $3.95 version. It's smaller and fits in your airplane real well. But that's not what people do. They take their airplane to their friendly mechanic. Not one of the good guys like Bob Gibson and other people here who know what they're doing. They're the friendly shade tree A&P who changes something. No, he doesn't get out a meter like that and find out what's wrong. He changes something. And when you come back, he says, I fixed the problem. And you say, oh, what owe you? And he says, $786. And you say, my gosh, what did you do? And he says, well, I changed your battery, and I changed the cable on the battery, and I changed the starter solenoid, and I changed the starter. And it works just fine now. Well, yeah, it works real fine, but you're too broke to go flying for months. Now, here's what you should have done. You take a meter, and you look there where the thing says to the starter circuit. And I'm going to go to another page here. I'm going to go, let's see. It says I can go right. That's what I was believing. So I'll go down there, it's just the easy way. I'm not real good at this. Well, keep clicking.
Forward.
That's current technology, Les.
I show you how to run it.
I hope I got the right amount of credit for you and not for all these videos you gave you.
There you go.
That's what got me started.
This is right off of SkyTech's website, so you can load it anytime you want to and print it. And that's how to go find out what's wrong with your starter.
Don't put it down, hang on to it.
Number one, step one, right up there. Put the meter across the battery. You got anything? Good, let's go on from there. Actually, you can do a quicker one of that. Turn the master on, turn the landing light on, and see if it lights up. Good start. Do we got any battery? Well, let's go to number two. There's number two. Put the meter across the starter, but you don't want to do that on one of our airplanes because you'd have to take the lower cowl off to get to it. But right by the battery is that starter solenoid. Just inboard from the battery, you can put your positive lead on the output of that starter solenoid and the negative lead on the case of the engine, some unpainted bulb. Stand back, get your buddy to turn the master on and push the start button and see if you see anything right there. Well, if you see 10 volts or more, it's time to look at the starter. If you don't, just work your way back. Checking the items that you see in this list till you find the place that there isn't anything. Now, I promise you that it won't cost you $795. And no, you do not have to be an A&P to do this. You may have to be an A&P to legitimately change out the parts when you find out what's wrong. But if you tell that shade tree fellow, if he's all you've got in the area, what I want you to do is change that starter solenoid right there. And if you've already looked and found that the price of one is really only about $28, he probably shouldn't charge you more than an hour's labor to do it. You're going to come out a lot cheaper. Now, I'm going to give you the story that I get on the telephone at least once a week. Well, my starter just won't turn this airplane over. The prop comes up on compression stroke, and I have to hit it 4 or 5 times, and it finally bumps over, and then it goes just fine. Oh, okay. Well, what's your battery voltage? Don't know. Well, have you looked at it? Well, no. Should I? Well, that'd be a good thing to do. Well, what would I look at it with? There's a thing called a voltmeter. Oh. Well, if you don't know any of this stuff, I hate to say this, but find yourself a good friend here in the AYA. There's lots of us who play with electricity, even if it doesn't have to do with airplanes. It might have to do with motorcycles or cars or whatever, and they can help you use a voltmeter, and it doesn't take long to learn. And it can sure save you a lot of money. And it also saved you several nights in East Armpit, Arkansas, while the local mechanic tries to fix your airplane. Typical problems are bad cable connections. Almost never on Grummans. The Grumman aircraft are built with wonderful cable. The ends are crimped on really good, but corrosion does get to you. That battery ground right there is one of the classic problems. Short piece of cable goes from the battery right on over to one of the pan bolts on the engine, and corrosion under that or loose bolt will cause that problem of boom, because the starter just isn't getting enough power to turn over. Another problem is bad starter solenoid. The contacts get pitted. It don't know you much. It's probably 30-some odd years old. And the contacts get pitted as it gets old, and they don't make as good contact as they used to. And so it just doesn't make good contact to deliver plenty of power to the starter. Last but not least, take that cowling off to get down to the starter. Eliminate everything else first. But you do it quickly. If you've got 10 volts or more right there, then the problem has to be either that cable or the starter. And that's the only time to start taking the cowling open with a starter problem. Now, anybody got any questions about starters or starting problems? Or did I cover that pretty good and we go on to charging systems? Yes, sir.
Is it okay to tax these?
Well, I'll tell my old story. And, I had a call about 5 years ago from a fellow that said, starter's no damn good. And I said, oh, what happened? He said, burned up. Burned up. Well, what'd you do? What's different? And he says, maybe the wind. What? He says, well, I landed out there on the lake like I always do, get a lake amphib, and I shut the engine down and I was taxiing back to the dock with the starter. And, well, I think I must have had too much headwind because I've done this for many, many times, but this time it fired up before I got there. I want the starter to last longer. You know, you can't win. You just can't win. No, I don't buy a taxi with the starter. By the way, SkyTech has a deal for you guys. If you want a starter, we sell to the AYA members the starter for your airplane, rebuilt, not a brand new one, but one that's come back because it was misshipped or we had sent out a new one in replacement for an old one. We rebuilt it. They're just like new. They've got a new warranty on them. And you guys get the 12-volt ones for $250, and you get the 24-volt ones for $300. That's a great Let's,
We email you?
Sure, you can email me, call me on the phone. There's I'll put some cards on the back table. Let's talk about alternators and regulators for a minute. This is one of our big problems right now because of the age of our aircraft. All of the stuff before the AG5s in the 5 series were equipped with Ford alternators, Ford regulators. A lot of the AA1s were actually more modern. Even the early AA1s had solid-state regulators on them. Motorola, yeah. And they don't have the problems that the vibrating reed Ford mechanical regulators have. I want to tell you an alternator story just like my starter stories. There's a friend of ours, another AYA member, flies Tiger, and he called up one day and he said, I'm just at my wit's end. He says, I've had my alternator changed, what he said, 3 times, and at when we go cross country with this plane, he was in a partnership, we'll go somewhere and the thing will not be charging. When sometime in the flight, it just quits charging. We land and we take this thing into the shop there and they change the alternator. And sure enough, when we leave, it's charging. But, it doesn't last very long. A few days later, it's not charging again. And we've done this 3 times at $1,000 a pop, approximately. If you're at one of the big airports like San Antonio International or something like that, and you go to the FBO there, and you've got your little Grumman with what the guy tells you is a dead alternator, and he charges you 4 hours at least of labor at his $150 an hour shop rate, and he charges you for an alternator, you're out an easy $1,000, if not more. Well, he says, I'm at wit's end. I can't just keep changing alternators. I don't know why these things go bad so quick. Well, we convinced him to bring it down to our neighborhood. Charlie Adams and I worked on it. The first thing we did was we lifted the cowling and we looked in and we saw this rusty blob there on the firewall. Fresh old Ford right out of the Ford factory in 1975. And we said, should we guess? Now, what we're supposed to do is whip a meter out and actually start measuring things. But did we even bother that day? I mean, we just changed it. It looked so bad, we just changed it. And of course, when you took it off the firewall, you looked on the back, and it has these these wire wound resistors on the back of one of those old things, and it was just it was almost rusted through the metal in most of the places. We just put a regulator on, have to have an electro delta there that, one of those black things that was Cessna, but it's legit on our airplane. We put it on and it worked just fine. He hadn't had an alternator problem since. Now, you would think one of these competent shops would have spotted that, but they don't know Grumman's, and they know that the alternator wasn't working. If the alternator isn't working, what do? You change the alternator. Well, our charging systems are closed-loop systems. The alternator works by spinning an electromagnet, that's the rotating part of the alternator, in a big coil, that's the stator of the alternator. And that's what produces the power. Well, if you haven't got any power to that rotating electromagnet, that we often refer to as the field, but actually it's the rotor, it isn't going to generate anything. Well, it gets that from the regulator. So, if your regulator isn't working, your alternator isn't going to work. Now, on your panel, you have the little breaker right there somewhere. Where's that regulator? Oh, there it is. There's the Ford mechanical regulator. Isn't that wonderful? You have got the alternator switch right there, and that goes to a 5-amp breaker, and your split master switch turns it on, and that's what enables the regulator. And the output of the regulator, the F terminal, goes to that field I was talking about, the rotating magnet in there. The purpose of the regulator is to switch power on and off that rotor. As the voltage gets too high, it turns it off. As the voltage gets too low, it turns it on. And it's that simple. 5-amp breaker right there, they go bad. They get high resistance. The switch, they get high resistance. And so what you begin to see is oddnesses like flickering ammeters. They're old. Sometimes you need to replace them. There's this wonderful overvoltage protection in our aircraft that doesn't do anything. This is called crowbar protection. It's a little bitty what?
Diode.
Yeah, a little bitty Seeger diode with a spade plug crimped on one end, and it's connected on the back of that breaker right there.
Switch.
Okay, on the switch. All right, it's on one. It's on the back of the switch. I've got one on the back of the breaker. I think they put them different places, different times. Guess what? It doesn't work. Its purpose in life was to blow that breaker if the regulator went bad and the voltage went up enough to boil the battery or hurt your radios. Well, that breaker is always 100% of the time protected by that diode blowing first. So, if you think you've got overvoltage protection in your original Grumman aircraft, you don't. So what to do? Well, I suggest that if you've got a Ford mechanical regulator, you change it before you have trouble. Now, there are good regulators out there. They're not expensive. They're less than $200. Zeptronics makes a nice one with overvoltage protection built in. Plain Power makes a nice one with overvoltage protection built in. And they regulate much more precisely than the old mechanical regulators. In fact, on both of those, you can set them to whatever you want. If you have religious issues about what voltage you ought to charge your battery at. Some folks do. I have people who tell me you have to set it to exactly 13.3 volts, and other people tell me, no, it's got to be at 14.5. I'll tell you, it doesn't make any difference to the battery, you know. Something over the, somewhere around 14 is fine. Works good. But change that regulator if you've got an old Ford mechanical and avoid problems in the future. The alternator itself was Ford. They're good alternators that lasted a long time. They're still available. They were used in a 1971 Ford F-150 pickup with air conditioning. But you can't just go to the store and get one of those because there's two differences between your aircraft version of that as it was modified and the original. One of them is the safety wire. The bolts that hold the case together are drilled and safety wired so that it doesn't shake apart in aircraft operation. The other thing is the brushes are not normal. You can go out and get regular carbon brushes for the Ford, but if you do that, don't spend much time flying at 10,000 feet or more, because the carbon brushes depend on oxygen in the atmosphere acting as a lubricant, so that they slide on the slip rings nicely. As your altitude goes up, the lubricity goes down, and you start wearing those brushes out very fast, and because of they're not lubricating well, they tear up the slip ring on the alternator. Aviation brushes designed for high altitudes are formulated with methyl salts and whatever that means, and they don't depend on the composition of the atmosphere for lubrication and will fly up to high altitudes. That was discovered by the air forces of the world in World War II when they started flying planes higher and higher. But anyway, that is the difference between taking your alternator down to depth point. Sir?
I heard from an old mechanic who told me, he said the difference in the alternators for a car is that car alternators generate interference above 108 megahertz. That's to protect the FM band of the FM radios in cars. And that aircraft alternators generate their interference below 108, which is where the navigation gear is. And having taken them apart and played with them and looked at feels around them, I've seen no difference.
I agree with you. There's no difference.
There's no difference.
That's not true.
Yeah.
When we first started testing our plane power alternators, the FAA made us do such things as do 100 hours at 28,000 feet. Now, so we got this big cabinet that we bought surplus from General Dynamics that was used for testing something for the Air Force, and it'll go up to 30,000 feet. And we added mechanical refrigeration to cool it off, and then we added some extra coils so we could park a tank truck of liquid nitrogen out back and flow through those to get to the temperature that you have at 28,000 feet. So full power, 28,000 feet, 100 hours. We used up 2 tank trucks of liquid nitrogen doing that. But that's when we did find out that their testing ideas are not totally crazy. That's when we found out about the brushes and had to go find the source of high altitude brushes. Don't take your alternator down to Pep Boys and have to fix it. Sir?
Some of the later model Tigers did have an old voltage relay on.
Yes, that's true. I think I've got that page here. That's a good point. There you go. In the later Tigers, 79?
78 and 9.
78 and 9, there's an overvoltage relay in here which just opens the power line to the regulator if the voltage gets too high. Works great.
Cheetahs also.
Okay? But 78 and 79 and later. How does this one reset, guys? You have to turn it back off and back on to reset it, right?
Right.
Yeah, you have to flip the alternator switch off and back up. Both the Zeptronics and the plane power has overvoltage built in, so you don't really need it, but it doesn't hurt having both of them there. Especially when you think how much money is in your panel these days. Sure. I've seen people flying with more money in their panel than the airplane cost when it's new. You really don't want a bad regulator causing your alternator to fry those radios. Highly unlikely, but good thing to think about. Okay, troubleshooting the alternator. Let's do a meter again. We did one of these this morning. We did a Cheetah 76, and the symptoms were it didn't charge at all. So, following the proper procedure, that means be lazy. And don't take the cowl off unless you have to. We took the voltmeter, and I'm going to go back a page because this was the very simple one. We looked to see if we had any voltage here when we turned the master, and we're not running the engine, let's be safe, we don't need the engine running for this. We turned on the master and the alternator switch and looked right there, the power lead into the regulator to see if it had anything there. It did. It had whatever voltage was in the battery. It was down to about 10 volts, but it showed up there. Now, if it hadn't, we would have looked for the split master switch to be bad. Look back on the back of that, or look for the breaker to be popped or open. But we had it there. So then, we said, okay, we got anything going out to the field? Yes, we got on the field terminal of that regulator, we had the same battery voltage there. Uh-oh, it's beginning to look awfully like we're going to have to take this cowling off. So just to be real sure, we turn everything off and we pull the field lead and switch this little meter to ohms, which measures resistance. And we measure the resistance of the field without having to take the cowling off. Well, sure enough, it says that everything's looking good. Now we're getting confused. The field looked to be 8 or 9 ohms. That's just fine. Anything other than wide open. So, no split cowl. We pulled the prop, and we pulled the cowl, and we got down there and reached in and grabbed the alternator, and the back of the alternator moves. So we, having demounted the alternator, never found any broken wires. Quite often the problem is broken field wire. Vibration, will cause it to break and crimp. And that would have been a nice cheap fix, but it wasn't so in this case. And when we took the alternator apart, the case it'd been rebuilt before by some unknown rebuild house. I hadn't heard of it before, but they had a sticker on it. But it was falling apart. So we put a new alternator on it, bottled everything back up, and everything's fine and working again. This is a case where the alternator really was bad. And they will happen. But being lazy, I like starting from the top, anything you can reach. Work on that with the meter. Make sure the component that you're going to replace is really bad, and then either yourself or your local mechanic can actually replace the device, and you can save lots of money and time. I advise, carry a little $3 to $5 meter. They don't weigh anything in your tool pack. You're airplane. Good to have. This is the, right here is the new regulator from Flame Power. I just brought it because it's new and you guys probably haven't seen one. How old is that? $100 for the set. It's about 150.
Hey, Les,
Yes.
for the regional directors in here, Rob Jones, we have been going to like Harbor Freight when they have their $2.99 little bolt ohm meter sales. We buy like 10 of them. We give them out as regional fly-in door prices to people who don't have one.
That's a good idea. Okay, thanks. This is the flame power regulator. It goes right where the big fat Ford was. This holes to mount it, and it's all solid state. When I was doing this design, I wanted to make it impossible for anybody to kill, to make it idiot resistant.
Does it use the same 4 mounting holes as the Ford?
2. The Ford just uses 2.
Okay, perfect.
It has a lot of others for other applications, but it does that.
Okay, perfect.
This one you can short the field output to ground. You can wire it backwards. You can mix up the wires anywhere you want on there. It don't make any difference. You may smoke some wires, you may blow some breakers, but you're not going to hurt this thing. Yes?
Ziptronics gives you a go light and a whoa light. And when you hook it up, if the wrong light comes on, you're supposed to check it out.
Okay. We didn't go that far. But it's good looking. We like it. What's it cost? About $150.
How much did Grumman for?
That's what I meant to you guys. Other people pay more. I'll have one more thing to say about regulators, and I'll see if I can remember what it was. Questions?
Quick question.
Yes, sir.
While you're designing new, do you ever consider putting like mil-spec connectors along with the connectors to get rid of both of the environment spade one terminals?
What we did, we're not using any spade terminals on this. We used ring lugs. We used regular barrier strip. And the reason we did that is a mechanic in the field. Okay, start with certification. We spent a little over $100,000 certifying that. We'll never get it back, but I guess it was fun. We figured the mechanic in the field has some wire strippers, and he probably has standard plugs that he can crimp up. If he doesn't even have that, we're using the type of barrier strip that has wire clamps, so he can just screw a wire under it if he doesn't put a lug on it. We thought about going to really nifty connectors, and there's a lot of good stuff available these days, and then we said, no, the guy out there in the field is putting it in, isn't going to have it. So we went rather simple. Now, this does have, I was going to tell you, you can also have an idiot light now, and it's legit with this regulator. It has an output drive for an idiot light, and you are allowed by our certification to put you an alternator light on the panel somewhere to show alternator fail if you want to do it.
Did it show fail for low voltage and under voltage, or just one?
It just one fail, says I quit.
You don't know what the other is.
Right. Sir?
You recommend that when you replace an alternator to go ahead and replace the voltage regulator at the
If
same time?
you have a solid state regulator, no. I mean, they should last forever. But if you've got a Ford mechanical, you bet. Replace it. Any of you, sir?
Now, one thing, regressing a little bit, fits in. If you still have that diode down there on your alternator field breaker going to ground and you put on a regulator that's got the voltage protection in it, take that thing off.
Yes, sir. Absolutely. Good point, Ken. I forgot that. If you've got that silly diode in your pre-78 AA5 series or AA1 series aircraft, and you put in a regulator that has over voltage protection, reach under there and cut that sucker out. You don't need that flash and a little bit of smoke wisping up from under the dash someday.
Yeah, plus that thing will pop and your breaker will pop and you will not reset it until you remove it from the circuit.
Right, because if it's short, it's short.
That's hard to do in flight.
Sir?
Do you recommend that kids certified self-alternators and voltages?
Most of us have a voltmeter these days, whether we know it or not. Our GPS or some other piece of navigation equipment, our engine monitoring equipment we put in our airplane usually has a voltmeter in it. And I certainly believe in it a lot more than I believe in that mechanical ammeter. If I didn't have a voltmeter from some other source like that, I use my GPS, I definitely would put a voltmeter in. As far as I'm concerned, that ammeter is worthless.
Voltmeters are much more accurate. You're worried about how much.
Sir, Mr. Mayor.
There's such a thing as an alternator gradually losing its output power, but it work or not work, or there's somewhere in the area in there that's not putting out quite enough power. And if you put a full load on your aircraft, turn auto pilot on and all that, and trip your light, trip the alternator out of the system.
That's a hard question to answer. Yes, alternators have problems. You have diodes open up. They're a three-phase generator, and they have 6 diodes or more, sometimes 8 in there. And if you lose a diode, you lose one of the phases, and you'll have 2/3 of the capability of the alternator. If you don't notice that it's whining a little more than usual, and with our good radios these days, you probably won't. Yes, you have now a 2/3 alternator. But the major thing I see is, like Hal's, and not your fault at all. When we start dealing with high current stuff, the big wire, the output wire from the alternator, if that connector gets a little corrosion in it, you suddenly got a big resistor back there at the back of the alternator, and instead of delivering power to what you want to deliver it to, it just gets hot there. So one of the things I always do when I'm changing an alternator is pull on those ring lugs, twist on those ring lugs, and if they don't look real good, put a new one on. Because it's these terminations right at the back of the alternator where they get a lot of vibration that I worry about. And that thing, yeah.
Talk about those terminals. You said they're cheap to replace, $135.
That was the labor getting to it.
Yes, basically. But the question is, there's no wire support on the back of the alternator.
Not the way Grumman designed it, no.
Should we have an AL plan for the tracking the wires?
It is so tight in there, you know, there's so little wire, and it is so tight that unless you are going to run new wire back up to the regulator,
I'm just going to do that anyway.
well, if you do, then by all means do that. That would be a good thing to do. But right now, the way it's crammed in there with that L in the baffling, it's just hard to get in there.
There's not much slack.
Sir?
What does that line?
Well, if you lose a diode in the alternator, you'll start getting some line. If you have an alternator whose output filter capacitor is bad, or very typically with the Ford alternators, which have an external big can condenser on the output, the wire breaks on it from vibration, then you're not filtering it out. So it's either you've got a diode going bad, or you've got that capacitor has gone bad or had the wire break. Easy enough to find. Any more questions? Sir?
You addressed it a little bit, you addressed the starter a couple of issues ago, flickering ammeter.
Yes, sir.
Where should I look on that?
Well, and I've got one to do tomorrow that
You want to do two?
Larry Kennedy has his problems. You know, there's a lot of things that can cause it, and quite often it's a regulator, especially if you have, again, the Ford mechanical.
This is up.
Okay.
I mean, it could get thin or not a few years.
Well, they're solid state. If they're going to go bad, they go bad.
Maybe more.
Usually either or. Now, there's two brushes that ride the slip rings on the alternator. And if they're getting an end of travel, you know, they're worn down to where they just don't have much spring left, they'll be making contact part of the time and not others, and that will certainly cause the flickering ammeter.
I notice the voltage goes up and down, sometimes the minus 15, it never drops below 13, 23. But the suggestion in the star was to check the contacts on the 5 amp circuit breaker.
Well, that's certainly true. And that switch, as I mentioned earlier.
No, I didn't do the switch, I did check, and I suppose it could be bad within the circuit breaker itself. I mean, all I can do is check it.
Can you duplicate this on the ground? Does it do it on the ground? Or just in fly?
I think it does it on the ground, but I'm not really looking.
Okay, if it does it on the ground, one of the straightforward things to do is jumper it. You know, jumper the switch, jumper the breaker, and that will quickly eliminate those things. Of course, a loose field lead going from the regulator down to the alternator, you know, the screw, the nut not tight, or the connector on the regulator can cause that same problem. From the regulator's F output down to the field terminal on the alternator. If that wire is not making good contact, I've taken them off and seen the nut loose down there, and it's just floating. The dirty ground will do it. Of course, both the regulator and the alternator get their ground through their mounting, you know, how they're bolted down. But that doesn't mean it's good. Oh, I was going to tell you the other thing to check every time when things aren't working right, especially if you just had an engine out. There's two braid straps that go from the engine mount to the engine. Because remember, the engine's mounted in rubber cushions. If you don't have that kind of a ground, those braid grounds across to the engine itself from the engine metal mount, then you're drawing all of your current through your throttle cable and your start heat cable. Not a good thing to do. When the guy told me one time that when he pumps his throttle, the thing cranks better. Yes. Sir?
I had one that plagued me for about 3 weeks, had 3 alternators. It was an A-plus lead run on top of the drain back hoses, A-plus from the output from the alternator going back, and actually moved at a bend of the conductor had moved over inside the shield, and it only grounded to the braided
Yes.
outside when it got warm.
Okay.
And I found it by just dropping everything, and I just started shutting it off.
Well, that's a tough way to go at it. Sir?
I was going to tell everybody why you're carrying your voltmeter doesn't do you no means good if you don't have a schematic. It takes photocopied schematic pages out of your maintenance manual, or better still, you go to Gary Boyd's website, Law Aviation or Law Country. He has beautiful color schematics for cheetahs and tigers.
Oh, yeah, they're wonderful. And they're much easier to read than these maintenance manuals.
And you print that and just carry it in the airplane with you. So that way, whether you're working on it or you have to turn it over to the system mechanic to work on it, you give them a schematic of what they're working on.
Yes.
That voltmeter doesn't do any good if you don't have a schematic.
Gary Vaught's website, aucountry.com. Sir?
When a regulator gives the signal to the alternator to deliver current load, is that alternator going full on in the road?
Yes, it's full on, full off. It's pulse width modulated is the proper term in electronics. It turns the alternator on until the voltage comes up that it's measuring comes up to a particular level, and then it turns it off. Shortly thereafter, the battery drops a little bit again and turns off. This may be that we use a set frequency of 380 hertz. That's the base, and then we widen the pulse as necessary. Now, that brings me to another discussion. Some of the folks in this organization who are gurus have complained about the fact that in our regulator we sample the bus. And I'll show you exactly. Let's see if I can get this alive again. Yes. Note that in the original Grumman, you have diagram, you have this lead coming from the output back to the regulator. And that's where the mechanical regulator sensed the voltage. That's that shielded wire you're talking about coming back from the alternator to the regulator. We didn't like that idea. We thought that, and neither do most car manufacturers these days, we didn't think we wanted to know what the output of the alternator was. We wanted to know what it was doing to the bus. So in the flame power regulator, we sample the power coming into the regulator, which is closer to the bus itself. And we say that's what we're going to regulate on, not way out there and several feet of cable away at the alternator. Well, enough folks have made enough objections that probably next year when we do our revision, we'll add another terminal to the regulator so that if you really want to use that wire, you can. But I'm not convinced that doing it that way was a good idea.
So that means if you're regulating, you don't need that wire?
That's correct. You just leave it out. I don't also like the idea of a wire that is connected to the output of the alternator floating back toward the panel with no fuse. But that's the way our planes are wired. Now that means if that wire shorts down at this end, it's not big enough to blow anything. It'll just sort of burn under your cowling. Didn't think that was a real good idea. Yes, sir. Sir.
Those, the alternator that we probably have, the most common one, how many amps can it put out?
60. The Ford alternator was designed to produce 60 amps at when your engine is turning about 2,500 RPM.
Okay, so 60 amps times 12 volts or
14 volts, I'd say.
That's like 700 or 800 watts.
Yes.
So that's like 1 horsepower. So does the
Yeah.
alternator switch 1 horsepower off?
Well, you know, when we're flying along, we're not running the alternator at that kind of power. Most of us don't draw unless we had pitot heat, landing light, everything else on. We're probably not, even with all that on, we're probably not consuming more than 30 or 40 amps. Just flying along, we're probably drawing less than 10 amps. Sir,
Okay, as an ex-racer, when I used to race my airplane in a tight race with the Horizon digital tap, which reads to the RPM, if you take your alternator during a race and take it out of circuit, just run your master on, alternator off, running everything off your battery in a race, I would pick up 9 to 11 RPMs. Doesn't sound like a lot, but that means I'm not using the alternator alone. That's a quarter knot.
okay.
In a half-hour race, that's an eighth of a mile. That's 15 seconds for me.
Okay.
And in a 3-hour race, you're supersonic.
Huh?
In a 3-hour race, you're supersonic.
Hey,
Yes.
you're not cheating, you're not trying.
You get no respect.
Yes, sir. The regulator's doing temperature
Race
compensation.
trophy, say it all.
Oh, no, before it had no temperature. That is 2 power resistors and 3 relays. It doesn't have any temp power. Beats me. By the way, your recombinant gas batteries, if you'll read the little ticky that comes with your Concord or Gill recombinant gas batteries, they want a slightly higher charging voltage than the old open cell lead acids. They say 14.2 or something like that, where a lot of the old originals, what was that thing that we supposedly had in our airplane that you can't buy anymore? Anyway, it's rebat. It's at 13.5 volts, but if you're using recombinant gas, you ought to crank it up to 14.2 or something.
So it's adjustable?
Yes.
Oh.
And I think most of the solid state regulators are adjustable. Okay, go out there and Ken.
Before we get out of here, I was asked a question, and it's embarrassing when I can't answer one. But they want to know why the Skytech starter stays engaged for maybe a second after you release it.
Okay, I'll tell you that.
I said, ask less.
Okay, the starter we normally use on the Grumman aircraft is a permanent magnet starter. Now, and it is solenoid engaged. It doesn't use a centrifugal Bendix drive like your old Prestolite. When you push the button, an electromagnetic solenoid pulls a plunger in, which pushes the pinion gear out into the ring. All very wonderful. Then it cranks, and your engine starts, and you let go of the push button, and that permanent magnet motor starts acting like a generator as it winds down. Now, the engine can't turn it because there's a one-way clutch, a sprag clutch between the starter motor and the pinion drive. So your engine spins on up, but the mass of the motor armature is generating electricity as it coasts down to a stop. Well, and that energy that it's generating keeps the solenoid pulled in for a second and a half or something, until the speed of the armature decays enough that it's generating enough voltage, and the snap, the spring brings it out. Now, there's 40-something thousand of those starters out there in the fleet. None of them have yet been damaged by that, but it does make a different kind of noise. And the wound field starters, of course, cannot generate any power like that. So our HT and our NL starters that are wound field do not exhibit that sort of funny action. Hey guys, flying's getting expensive. Gas is high. Avionics is expensive. Hangar rent's going up. Insurance is going up. But we don't have to spend a fortune maintaining the electrical systems on our aircraft by turning it over to people who don't know what they're doing. If you don't want to do the troubleshooting yourself and pinning it down to the components that need to be replaced, then for gosh sakes, take your plane to people that you know here in the AYA, that know our airplanes, Ken, Bob, John, Fletcher, all the people who really know our airplanes and know how to work on them. Because they'll only charge you for fixing what's broken. That's all.
Thank you.